Look up, way up in the sky. That's our sun. It's a giant ball of burning gas, the big boss of our solar system. Planets, asteroids, comets, they all dance around the sun. Why? Because the sun has the most mass and the strongest gravity. Gravity is like a cosmic magnet. The sun is incredibly hot, much hotter than the hottest summer day you've ever experienced. It's so hot that it glows, and that light and heat travel across millions of miles of space to reach us here on Earth. Without the sun, our planet would be a frozen, lifeless rock. The sun is like a giant engine, constantly churning and burning, creating a tremendous amount of energy. We see that energy as light and heat, but the sun also releases other types of energy like X-rays and gamma rays. Luckily for us, Earth's atmosphere protects us from most of this harmful radiation. The sun is a fascinating and complex object, a giant ball of plasma where electrons roam free. It's constantly changing and evolving. Scientists are still working to unlock all of its secrets. But one thing is for sure, the sun is essential to our existence. It's the powerhouse of our solar system, the giver of life, and a source of endless wonder. So what is the sun made of? It's mostly hydrogen and helium. These are the two simplest and most abundant elements in the universe. Think of hydrogen as the basic building block, and helium, it's what you get when you fuse hydrogen atoms together. But the sun isn't just a big ball of these two gases. It also contains trace amounts of other elements like oxygen, carbon, and iron. These elements, though present in smaller quantities, play an important role in the sun's behavior. They affect its temperature, density, and energy production. Think of it like baking a cake. You need flour, sugar, and eggs as your main ingredients. But a pinch of salt or a dash of vanilla extract can really enhance the flavor. Similarly, these trace elements add complexity and nuance to the sun's composition. Understanding the sun's recipe is crucial for astronomers. It helps them understand how stars form, evolve, and eventually die. By studying the sun, we learn about the life cycle of stars throughout the universe. Now let's talk about how the sun generates all that energy. The secret lies in its core, where the pressure and temperature are unimaginable. Here, hydrogen atoms are constantly colliding with each other. These collisions are so powerful that they fuse the hydrogen atoms together. This process is called nuclear fusion. During nuclear fusion, hydrogen atoms combine to form helium. The helium atom they create has slightly less mass than the original hydrogen atoms combined. So, where does that missing mass go? It gets converted into energy, according to Einstein's famous equation, EMC2. This energy is released in the form of light and heat, which radiate out from the sun's core. It takes hundreds of thousands of years for this energy to reach the sun's surface and escape into space. But once it does, it travels at the speed of light, reaching Earth in just 8 minutes. This is how the sun powers our solar system. Imagine the sun like an onion, with multiple layers stacked on top of each other. Each layer has its own unique properties and plays a crucial role in the sun's overall behavior. At the heart of the sun lies the core, the hottest and densest part. This is where nuclear fusion takes place, generating the sun's energy. Moving outward, we encounter the radiative zone. Here, energy is transported through radiation, where photons bounce around like ping pong balls. Next comes the convective zone, where energy is transported through convection. Think of a pot of boiling water. Hot plasma rises to the surface, cools, and then sinks back down. This creates a churning effect that helps to distribute heat throughout the sun. Finally, we reach the sun's atmosphere, which consists of 3 main layers: the photosphere, the chromosphere, and the corona. The photosphere is the visible surface of the sun, the layer that emits the light we see. The chromosphere is a thin layer above the photosphere, visible during solar eclipses. And the corona is the outermost layer, extending millions of kilometers into space. By studying these layers, scientists can learn about the sun's magnetic field, its rotation, and its overall activity. The sun may seem like a constant presence in our sky, but it's far from being calm and predictable. Our star has a fiery temper, unleashing bursts of energy and displaying dark blemishes on its surface. These phenomena, known as sunspots and solar flares, are a testament to the sun's dynamic nature. Sunspots appear as dark patches on the sun's photosphere, cooler regions caused by intense magnetic activity. Solar flares, on the other hand, are sudden bursts of energy like gigantic explosions on the sun's surface. They occur when magnetic energy that is built up in the sun's atmosphere is suddenly released. Solar flares release enormous amounts of radiation, including X-rays and gamma rays. These solar events, while fascinating to observe, can have tangible effects on Earth. Intense solar flares can disrupt radio communications, interfere with satellites, and even cause power outages. These events highlight the sun's power and our reliance on its stability. Let's talk about gravity, the invisible force that governs the cosmos. The sun, with its massive size, exerts a powerful gravitational pull on everything in its vicinity. This gravitational pull is what keeps the planets of our solar system in orbit around the sun. Imagine a ball on a string swinging in a circle. The string represents the sun's gravity, constantly pulling the ball, our planet, towards it. The ball's momentum keeps it from crashing into the center, resulting in a stable orbit. But the sun's gravity doesn't stop at the planets. It also rains in asteroids, comets, and even tiny particles of dust, keeping them bound within its influence. Without the sun's gravity, the planets would fly off into space, lost in the vastness of the cosmos. The sun's gravitational embrace is what holds our solar system together. The sun is more than just a celestial object, it's the lifeblood of our planet. Its energy, traveling millions of miles through space, sustains life on Earth in countless ways. Plants, the primary producers of our food chain, rely on sunlight for photosynthesis. They capture the sun's energy and convert it into chemical energy, stored in the bonds of sugars. This process not only provides nourishment for plants, but also releases oxygen into the atmosphere, the very air we breathe. The sun's warmth drives Earth's climate and weather patterns. It heats the Earth's surface unevenly, causing air and water to circulate, creating winds, ocean currents, and the water cycle. These processes distribute heat and moisture around the globe, shaping our planet's diverse ecosystems. The sun's energy also powers renewable energy sources like solar power. By harnessing the sun's energy, we can generate electricity, heat water, and even power homes and businesses. The sun's influence extends far beyond our planet, shaping the environment of our solar system. Its powerful solar wind, a stream of charged particles constantly flowing from the sun's corona, interacts with planetary atmospheres and magnetic fields, creating stunning auroras and influencing planetary evolution. Imagine the solar wind as a giant cosmic broom, sweeping through the solar system, carrying with it charged particles and magnetic fields. When these particles collide with planetary atmospheres, they excite atoms, causing them to glow. This creates the breathtaking auroras, dancing lights that illuminate the skies near Earth's poles. The sun's magnetic field, carried by the solar wind, interacts with the magnetic fields of planets, creating a complex interplay of forces. These interactions can influence planetary atmospheres, stripping away lighter elements over time and shaping their compositions. Understanding the sun's influence is crucial for comprehending the dynamics of our cosmic neighborhood. As we conclude our exploration of the sun, we are left with a profound sense of awe and appreciation for our celestial guardian. The sun, a giant ball of burning gas, is the powerhouse of our solar system, the source of our planet's life-giving energy, and a constant presence in our sky. From its composition of hydrogen and helium to its layered structure and dynamic phenomena like sunspots and solar flares, the sun is a fascinating object of study, constantly revealing new secrets to curious minds. Its immense gravity holds our solar system together, while its energy sustains life on Earth. The sun's influence extends far beyond our planet, shaping the environment of our solar system and interacting with planetary atmospheres and magnetic fields. Understanding the sun is crucial for comprehending our place in the cosmos and appreciating the delicate balance that makes life on Earth possible. Let us cherish our stellar guardian and continue to unravel its mysteries for generations to come.